In this project, we present a fully functional pipeline that goes from Blender to Python back to Blender again, which takes a plane in Blender made of glass, computes the shattering for the blender using an algorithm based off of Smith's paper, and then finally goes back to Blender and renders the animation for the shattering.
We first establish a baseline using Blender's built-in shattering calculation. What we do is we display the fracture on the frame, and then we shoot a bullet represented by a ball through a part of the frame, and let the physics take over. The result is something that looks quite realistic, and we want to try and emulate this or improve upon this for our method, given the constraints that we have. Now here are our results. As you can see, the shattering works quite well around the region of the ball. There are a couple other minor differences, such as the weight of the glass and the fact that the shards fall through the surface. All in all, though, we consider this a significant success and a great adaptation of the algorithm to our circumstances.
We attempt to find where the object's constraints break given impulse. Our algorithm takes in a force, and we solve a linear system to find the equilibrium forces and then break the constraints if the force exerted in response exceeds the limits. We actually break our impulse into a schedule of forces. For example, 10 force distributions according to this schedule. We want to load forces slowly because it doesn't actually make sense if we have broken constraints that are exerting more force than they should be during equilibrium. Since our object is rigid and doesn't have any internal movement, we can avoid simulating the full dynamics of a lattice of point masses and springs by aggregating the external forces and then simulating the entire object at once.